Hello, good day everyone. You are welcome back. I want to show you how to solve this question without the use of a calculator. We are asked to calculate the length of this red line. We have the length of this side to be 4 meters and this is 12 meters. We can see this line bisects this side here. That is, this side and this side are equal in length. Let's assume the lengths to be A each. This angle and this angle are right angles, and we have the size of this angle to be x. So how can we solve it? Well, there are quite a number of methods you can use to solve, but in this video I will show you two which I think are the best. Now the first method we are going to use, we first label this side B. Now from this triangle we can see it is a right angle triangle, so we can use the Pythagorean theorem. The Pythagorean theorem states that the square of the length of the hypotenuse of a right angle triangle is equal to the squares of the length of the two other sides. The hypotenuse is the side facing the right angle, which is this side here. So using the Pythagorean theorem, a plus a all squared equal to b squared plus 12 all squared. A plus a is 2a. 2a all squared is 2a times 2a, which is 4a squared. While here, 12 all squared is 12 times 12, which is 144. So 4a squared equal to b squared plus 144. We keep the equation aside. Now still from this triangle, we know since it is a right angle triangle and we have the size of this angle to be x, this angle must be 90 degrees minus x. Now from this triangle also, it is also a right angle triangle. So since this is 90 degrees minus x, this must be 90 degrees minus 90 minus x. 90 degrees minus 90 degrees is 0. Minus x is plus x. So the angle is x. Now look at this triangle and this triangle. They both have a right angle, an angle x and an angle 90 degrees minus x. That means they are similar. So if we take the ratio of their sides, this side facing angle 90 degrees minus x divided by this side facing the right angle must be equal to this side facing angle 90 degrees minus x divided by this side facing the right angle. Let's say c. So b over 2a equal to 4 over c. Cross multiply. Now b times c equal to 4 times 2a. B times c is bc. 4 times 2a is 8a. So bc equal to 8a. We keep it aside. Now we are going to make use of the Taylor's theorem. The Taylor's theorem stated that if a line is drawn parallel to one side of a triangle intersecting the other two sides in distinct points, the sides intersected are divided in the same ratio. That is, if you come here to this triangle, draw a line parallel to this side from this point down here, this side and this side will be divided in the same ratio. So since this side is bisected, this side must also be bisected. That is, since its whole length is 12 meters, this part and this part each will be half 12 meters, which is 6 meters. Recall, from this point to this point, we assume the length to be c. So since this part is 6 meters, if we let this be d, c equal to 6 plus d. We know since this angle is a right angle, this must also be a right angle. And since this is x, this must be 90 degrees minus x. Now look at this triangle and this triangle. They both have a right angle, an angle 90 degrees minus x, and an angle x. That is, they are similar. So if we take the ratio of their sides, this side facing angle 90 degrees minus x divided by this side facing the right angle must be equal to this side also facing angle 90 degrees minus x divided by this side facing the right angle. So d over 4 equal to 4 over d plus 6. If we cross multiply now, d times d plus 6 equal to 4 times 4. D times d plus 6 is d squared plus 6d. Here 4 times 4 is 16. So d squared plus 60 equal to 16. If we bring back 16 to the left hand side of the equation, d squared plus 6d minus 16 equal to 0. We are going to solve this equation by factorization. To solve by factorization, we need two numbers in which their sum value will be equal to this and their product will be equal to the product of this and this. That is, if you assume the numbers to be p and q, p plus q must be equal to 6d and p times q must be equal to minus 16d squared. What are the numbers? They are 8d and minus 2d. 8d plus minus 2d is 6d, which is this, and ad times minus 2d is minus 16d squared, which is this. So we replace this 6d with 8d minus 2d. Now d squared plus 8d minus 2d minus 16 equal to 0. From here, d squared plus 8d, if we factor out d, it will be d open bracket d plus 8. And from here, if we factor out minus 2, it will be minus 2 open bracket d plus 8. Since d plus 8 is a common factor, we also factor it out. So d plus 8 open bracket d minus 2 equal to 0. And from this, it's either d plus 8 equal to 0 or d minus 2 equal to 0. If we make d the subject in both equations, d equal to minus 8 or d equal to 2, d is length of this side, so it can't be a negative number. Therefore, this cannot be the answer, so d equal to 2. If you substitute here, c equal to 6 plus 2, which is 8, so c equal to a. We also come here and substitute, so b times 8 equal to 8a. This 8 cancels this 8, so b equal to a. If we also come here and substitute that, now 4b squared equal to b squared plus 144. Subtract b squared from both sides. Here b squared minus b squared is 0, while here 4b squared minus b squared is 3b squared. So 3b squared equal to 144. Take the square root of both sides. Here square root of 3b squared is b root 3, while here square root of 144 is 12. 12 is also 4 times 3, and 3 can also be written as root 3 times root 3. This root 3 cancels this root 3. 4 times root 3 is 4 root 3, so b equal to 4 root 3. So using the first approach, the length of this straight line, which you are asked to calculate, is 4 root 3 meters. Now we'll go to the second approach. And please don't forget, it takes me a lot of hard work to make this video, so you can support me and do me a favor by subscribing, liking and sharing. Now all you have to do here is draw a line that connects this vertex and this point here. We all know that since this angle is x, this must be 90 degrees minus x, and from this triangle, this line bisects this side of it. That means it is a median of the triangle, and you can see the median is at right angle with the side it bisects. The only two types of triangle that has its median perpendicular to the side it bisects is either an equilateral triangle or an isosceles triangle. But this triangle is clearly not an equilateral triangle, therefore it is isosceles. In an isosceles triangle, there are two sides which are congruent. That is this side and this side. We assume their length to be c. We know the angles facing them are congruent. So since this is 90 degrees minus x, this must also be 90 degrees minus x. And since this is x, this must also be x. Now look at this quadrilateral. It has two opposite congruent angles, which are this right angle and this right